So this is implicit differentiation. The first example, we're going to find dy over dx of y to the fifth plus 2y equals x squared. And for each term, you're going to multiply by d over dx. So for the first term, which is y to the fifth, the derivative would be 5y to the fourth dy over dx. And for the second term, it's going to be, the second term is 2y, so the derivative is only 2, and since there was a y, you're going to put dy over dx. And then the third term is x squared, so the derivative is 2x with no dy over dx because there was no y. And then you're going to move over here, which is 5y to the fourth dy over dx plus 2 dy over dx equals 2x. And since this term and this term, they both have dy over dx, it's like you can group them together or factor out a dy over dx. And you're going to get 5y to the fourth plus 2 equals 2x. And since this is now factored out, they're multiplying, so you can divide by this expression, and you're gonna, to get this by itself, so you're gonna get dy over dx equals 2x divided by 5y to the fourth plus 2. And for the second example, cosine y plus x squared y squared equals 5y. And the derivative of cosine is negative sine, and you're going to do negative sine y dy over dx plus x squared 2y dy over dx plus y squared times 2x equals 5 dy over dx. And basically for this middle term, or this middle expression, you did the product rule, which is why this happened right here. And then you're going to get negative sine y dy over dx plus 2x squared y dy over dx plus 2xy squared equals 5 dy over dx. Because the derivative of 5y is 5, and since there was a y, you're going to put dy over dx. The derivative of here, you're going to simplify this to get this from the product rule, and negative sine y is the derivative of cosine y, dy over dx. And so negative sine y dy over dx plus 2x squared y dy over dx minus 5 dy over dx equals negative 2xy squared. So what happened here is I underlined, or I identified all of the ones that have dy over dx, which is here, here, and here. And I want my dy over dx to be alone, so I'm going to move this to this side and this to this side. And I got this. And then, once again, you can factor dy over dx because all of these, this one, and this one, all have dy over dx, so we're going to factor it out. And you're left with negative sine y plus 2x squared y minus 5 equals negative 2xy squared. And you're going to divide this and divide on this side. So this cancels here. And then dy over dx equals negative 2x squared divided by negative sine y plus 2x squared y minus 5. For the last example, we're going to find the derivative of x equals tangent y. The derivative of tangent is secant. So for each term, again, you're going to do d over dx. And for this one, you're going to do d over dx x equals d over dx tangent y. And then this turns into 1 because it's dx over dx, so it will just turn to 1 equals secant squared y, which is the derivative of tangent y, dy over dx, which is the derivative of y. So then you're going to divide by secant squared y on both sides. So you're going to get dy over dx equals 1 over secant squared y.